There is a real planet confirmed by astronomers, given a catalog number that is twice the size of Earth and potentially made largely of diamond. It's called 55 Cancri E. It's real, it exists right now, and tonight we're asking the impossible question: what if it was heading toward us? What does a diamond planet actually do when it hits Earth? Stay with me because the answer to that last question is something no jeweler has ever told you about diamonds. Before we get to the impact, I need to tell you something about diamonds that completely changes how this collision plays out, something that makes diamond far more dangerous and far more fragile than you think. 55 Cancri E is twice Earth's diameter, 8 times its mass, and orbits its star in just 18 hours, so close that its surface is a lava ocean at 2,400 degrees. But deeper in the mantle, under pressures of millions of atmospheres, carbon crystallizes into diamond. The diamond layer could be hundreds of kilometers thick, the largest diamond in the known universe. And it's real, right now, 41 light-years away. Here's what I haven't told you yet, and this is the part that changes everything about the impact. Diamond under the pressures of a planetary collision doesn't behave like the diamond in a ring. What happens to it is genuinely shocking. Diamond is the hardest natural material, but hardness and impact strength are different things. Diamond is brittle. Hit it hard enough and it shatters. That's how diamond cutting works. Under hypervelocity impact, materials are compressed so rapidly that crystal structure breaks down entirely. The diamond doesn't stay diamond. It becomes a plasma of carbon atoms. Briefly, before the energy disperses, the hardest material in the world becomes gas in a fraction of a second. Now here's the part that nobody would predict. Months before the diamond planet touches Earth, the destruction has already begun. And it starts with something you'd never expect to be the first sign. A planet twice Earth's size approaching would disturb the outer planets first. Neptune's orbit shifts, earthquakes increase globally as tidal forces build, volcanoes awaken worldwide, and in the sky a growing point of light, brightening night by night. A diamond world, glittering in reflected sunlight, the most beautiful thing anyone has ever seen in the night sky, growing larger every night, until there is no more night. The moment of first contact is not what most people imagine. The diamond surface doesn't matter at all. Here's what actually happens in the first millisecond, and it rewrites everything you think about planetary collisions. At hypervelocity, material properties become irrelevant. Diamond, iron, ice, at those speeds, everything behaves the same. The energy at the contact point converts everything to plasma Earth material and diamond material alike, stripped of crystal structure, existing briefly as superheated ionized gas at millions of degrees. The diamond planet doesn't carve through Earth, it merges with it. Two worlds becoming one in an explosion that briefly outshines the sun. The diamond is gone before it arrives. But here's what happens after, and this is the part that actually gives me chills. What the impact leaves behind in the debris field is something extraordinary, and it involves every diamond you've ever seen in a jewelry store. The impact debris field is extraordinarily carbon-rich. As it cools in space over thousands of years, carbon under rapid cooling crystallizes into diamond. The asteroid belt and meteorites already contain nanodiamonds from ancient impacts. A diamond-planet collision would seed the solar system with carbon-rich debris, some of it cooling in vacuum, forms diamonds, not planetary-scale ones, but real diamonds, scattered across the solar system, remnants of the most extraordinary collision in Earth's history. Now here's the question everyone's been waiting for. After a planet-sized diamond hits Earth, are there any diamonds left? I promised you an honest physics answer, and here it is. Mostly, no. Planetary collision energy converts virtually all material to plasma. But in the debris field ejected into orbit, some material cools rapidly in vacuum. Carbon crystallizes. Nanodiamonds form. Real diamonds scattered across the solar system, remnants of a collision. Not the diamonds you imagined, but proof that the universe recycles even its most extraordinary materials into something beautiful. And here's what the existence of 55 Cancri E tells us about the universe, something that fundamentally changes how you understand what a planet can be. We assumed other planets were variations on ours. Then we found diamond worlds, lava worlds where rock rains from the sky, planets where it rains iron, water worlds with no land. The universe is far more creative than our solar system suggests. The variety of planets that exist dwarfs anything we imagined, and we've only looked at a tiny fraction of the galaxy. And here's the final thought about every diamond on Earth right now that changes what they mean forever. The diamonds in jewelry stores formed 1 to 3 billion years ago, deep in Earth's mantle at 60,000 atmospheres of pressure, at 1,300 degrees. then brought to the surface in volcanic eruptions traveling from 150 kilometers underground in hours. The diamond in someone's ring is older than the dinosaurs, forged in conditions almost as extreme as another planet's interior, traveled to the surface in a natural rocket made of magma. Every diamond is already a piece of the extraordinary. We just stopped noticing. The universe contains wonders that make every human achievement look modest, and yet we're the ones who figured out they exist. That's what this channel is about. Subscribe right now, hit the bell. Every week we explore something that changes how you see reality. Share this with someone who wears a diamond and doesn't know its full story. See you in the next one.